What if you could send a text message to the past? Not to someone across the country, to yourself. 10 years ago. Before the mistake, before the loss, before everything changed. There is an anime series called Steins Gate. It follows a young self-described mad scientist named Rintaro Okabe, who accidentally discovers that a modified microwave, connected to a phone, can send text messages into the past. What starts as a joke in a rented lab becomes a catastrophe that splinters reality into branching timelines. The show is beloved because it takes the idea seriously. It does not treat time travel as magic. It treats it as a problem. A deep, dangerous, potentially unsolvable problem. And here is the thing. The science behind Steins Gate is not pure invention. The device at the center of the story is based on a real concept in theoretical physics. It is called the tachyonic antitelephone. And the reason it was invented was specifically to prove that sending signals into the past is impossible. Let us go back to the beginning. The year is 1907. Albert Einstein is 28 years old and already rewriting the laws of physics. 2 years earlier, he published the special theory of relativity. One of its core conclusions was absolute. Nothing with mass can travel at or faster than the speed of light. The speed of light is a universal speed limit. Hard, unbreakable, final. But Einstein, being Einstein, could not stop asking uncomfortable questions. What if something could travel faster than light? Not a massive object, not a spaceship, but some hypothetical particle that was born already moving faster than light and never had to cross that barrier? What would that mean for physics? What would that mean for time? The answer turned out to be deeply unsettling. Because in the mathematics of special relativity, a particle moving faster than light does not just move quickly through space. It moves backward through time. Not metaphorically, mathematically, literally. A decade after Einstein raised the question, a physicist named Richard Tolman took it further. Tolman asked a very specific and very dangerous question. If faster-than-light particles exist, could they be used to send information into the past? Could you build a device that uses them as signals? A telephone, but one that calls yesterday. Called it the tachyonic antitelephone. The name itself is a warning. Anti, against. A telephone that works against the normal flow of time. And the word tachyon comes from the Greek word for swift. These hypothetical faster-than-light particles that would make the whole thing possible. Now, before we go further, let us be clear about what tachyons actually are, or more precisely, what they might be. Because no tachyon has ever been observed. No experiment has ever detected one. They exist only in mathematics. In theory, a tachyon would be a particle with an imaginary mass. Not small mass, not zero mass, imaginary mass. In mathematics, imaginary numbers are perfectly valid tools. They appear constantly in quantum mechanics and electrical engineering. But what imaginary mass would mean physically, for an actual particle in the real world, is something nobody fully understands. What we do know from the mathematics is this. A tachyon could never slow down to the speed of light. Just as a normal particle can never speed up to the speed of light, a tachyon is permanently stuck on the other side of that barrier. Always faster. Always moving in a way that, from certain reference frames, looks like moving backward in time. And this is where things get dangerous. To understand the tachyonic antitelephone paradox, we need to run a thought experiment. Kind Einstein loved. Simple ingredients. Devastating consequences. Meet Alice and Bob. They are two physicists. They are very far apart from each other, and they have agreed on a set of rules. They each have a tachyonic antitelephone, a device that can send messages faster than light. And because of special relativity, faster than light means those messages can arrive before they were sent. Here are the rules they agreed on. Alice will send Bob a message at exactly 3 o'clock, if and only if she does not receive a message from Bob by 1 o'clock. Bob will send Alice a message at 3 o'clock, time to arrive at 1 o'clock, if and only if he receives a message from Alice. Read those two rules again slowly, because something breaks. If Alice does not receive Bob's message by 1 o'clock, she sends her message at 3 o'clock. Bob receives Alice's message, so Bob sends his message back, time to arrive at 1 o'clock. But now Alice receives Bob's message at 1 o'clock, which means she should not have sent her message, which means Bob never receives Alice's message, which means Bob never sends his reply, which means Alice never receives anything at 1 o'clock, which means she sends her message at 3 o'clock, which means Bob receives it, which means... You see the problem. The communication happens if, and only if it does not happen. The system is logically self-contradicting, not just confusing, not just hard to follow. Actually, mathematically, provably broken. This is the tachyonic antitelephone paradox, and it was constructed deliberately as a reductio ad absurdum, a proof by contradiction. If tachyons can carry information, and if special relativity is correct, then paradoxes like this one are not just possible, they are unavoidable. Therefore, something must be wrong. Either tachyons cannot carry information, or tachyons do not exist, or special relativity is incomplete. The paradox is related to something you may have heard of, the grandfather paradox. Classic time travel thought experiment where you go back in time and prevent your own grandfather from meeting your grandmother, which means your parent was never born, which means you were never born, which means you never went back in time, which means your grandfather and grandmother did meet, which means you were born, which means you did go back, around and around forever. The tachyonic antitelephone is the scientific version of that paradox. Less dramatic in its ingredients, just two physicists and a device, but equally fatal to the concept of sending information into the past. Now let us look at the mathematics more carefully, because the paradox was actually visualized before Tolman even formulated it. In 1911, a physicist named Paul Ehrenfest used something called a Minkowski diagram. A Minkowski diagram is a way of drawing space-time. Time runs vertically. Space runs horizontally. Every event is a point on the diagram. Every path through space and time is a line. On a Minkowski diagram, light always travels at 45 degrees. That diagonal line is the speed limit of the universe. Normal particles travel at angles closer to vertical, slower than light, moving mostly through time rather than space. A tachyon would travel at an angle closer to horizontal, more through space than time, and in certain reference frames, that line tilts below horizontal. particle is moving backward in time. Here is what Ehrenfest showed. A signal sent from event O in reference frame B1 travels at near infinite speed in two opposite directions toward events M and P. In reference frame B1, event O happens before event M. Cause before effect. Everything normal. But in a different reference frame B2, event M happens before event O. The effect precedes the cause. The signal arrives before it was sent, and both reference frames are equally valid. Neither is more correct than the other. Special relativity demands that. This is the deep problem. It is not about confusion or misreading clocks. It is about the structure of space-time itself. Special relativity tells us that simultaneity is relative. Two observers moving at different velocities can genuinely disagree about the order of events. For events connected by signals slower than light, this is fine. Everyone agrees on cause and effect. But for events connected by signals faster than light, the order of cause and effect becomes a matter of perspective. And a universe where cause and effect are optional is a universe where physics collapses. So why do physicists not spend more time on this? Why is the tachyonic anti-telephone not front-page news every year? The answer is almost disappointingly practical. Because tachyons have never been found. Every experiment designed to detect faster-than-light particles has come up empty. In 2011, there was a famous moment of excitement. A particle physics experiment in Europe called OPERA reported that neutrinos had traveled from CERN in Switzerland to a detector in Italy, 60 nanoseconds faster than light. 60 nanoseconds is 60 billionths of a second. Barely a whisper of a difference. But it was enough to set the physics world briefly on fire. Had someone finally detected something moving faster than light? The answer was no. After months of investigation, the anomaly was traced to a loose fiber optic cable and a faulty oscillator clock. A hardware error, not a revolution in physics. The neutrinos had not broken the speed limit. The equipment had simply made a mistake. That episode illustrates something important. The speed of light as an absolute barrier is not just a rule we follow because Einstein said so. It is one of the most tested and verified results in all of science. Every precision measurement ever performed is consistent with nothing traveling faster than light. The barrier holds. But there is a subtlety here worth understanding. Tachyons do appear in certain areas of modern physics. Not as physical particles you could use to send a message, but as mathematical objects in quantum field theory. In that context, a tachyonic field does not represent a particle moving faster than light. It represents an instability in the field itself, a sign that the system wants to settle into a lower energy state. This kind of tachyonic behavior actually played a role in the Higgs mechanism, process by which particles acquire mass. So the word tachyon in modern physics does not automatically mean faster than light travel. It often means something far more technical and mundane. The tachyons of popular culture, the ones in Steins Gate and science fiction films, are a different creature entirely. They are the poetic version, the literary version, particles that carry messages through time because the story needs them to. And here Stephen Hawking had something sharp to say. He pointed out a simple and elegant argument against time travel of any kind. If time travel to the past ever becomes possible, at any point in the future of our civilization, or any other civilization in the universe, then we should already be receiving visitors from those future times. Tourists from centuries ahead. Historians observing our era. Someone curious enough to come back and look. And yet we have no credible evidence of any such visitors. No verified contact. No confirmed message from the future. Hawking called this the chronology protection conjecture. The idea that the laws of physics conspire to prevent the creation of time machines, not because of some mystical force, but because the mathematics of general relativity seems to generate effects that destroy any attempt to create a closed time loop. Quantum effects near a potential time machine grow without limit and tear it apart. Nature protects its own timeline, or at least that is the conjecture. It has not been proven, but the absence of time travelers is a pretty compelling piece of evidence. The same logic applies to the tachyonic antitelephone. If faster-than-light communication were possible, we should have already received a signal from the future, some message sent by a civilization that had mastered tachyon communication centuries from now. A warning, a greeting, a wrong number, anything. The silence speaks. There is something philosophically rich about all of this. The tachyonic antitelephone was not invented to describe something real. It was invented to demonstrate why something is impossible. It is a proof built out of absurdity, a reductio ad absurdum dressed up in the language of physics. You take the premise that faster-than-light signaling is possible. You follow the mathematics honestly and carefully, and you arrive at a universe where communication happens if and only if it does not happen, where cause follows effect, where logic eats itself, and you conclude that the premise must be false. It is the same method Euclid used to prove that there are infinitely many prime numbers. The same method mathematicians have used for thousands of years. Assume the opposite of what you want to prove. Follow the logic. Reach a contradiction. Conclude that your assumption was wrong. The tachyonic antitelephone is that method applied to the structure of time itself. But here is what makes this story genuinely beautiful. Physics does not claim to know everything. Every theory we have works until someone finds a case where it does not. Special relativity is extraordinarily well tested. The speed of light as a barrier is extraordinarily well established. But the history of science is also the history of surprises. Newtonian gravity worked perfectly for centuries, until Einstein showed it was an approximation. Quantum mechanics contradicted every classical intuition, and turned out to be correct anyway. Nobody is seriously proposing that tachyons exist. Nobody is building a tachyonic antitelephone. But the questions this concept forces us to ask are among the deepest in all of physics. What is causality? Is the order of cause an effect of fundamental law of nature, or an emergent property of the universe we happen to live in? Is time travel genuinely impossible, or just impossible given what we currently know? Is the silence from the future proof that the future cannot reach us, or just proof that nobody has tried yet? Steins Gate understood something that a lot of science fiction misses. Time travel is not exciting because it would be fun. It is exciting because it is forbidden. Because everything we understand about physics says it should not work. And yet the human desire to reach back into time, to fix what broke, to warn who was lost, to say what went unsaid, is so powerful that we keep asking the question anyway. The tachyonic antitelephone is physics saying clearly and firmly, no, cannot call the past. The mathematics will not allow it. Causality will not allow it. The universe will not allow it. And yet, the fact that we had to build an entire theoretical device just to prove it impossible says something remarkable about how seriously physics takes the question. You do not construct elaborate proofs against things that are obviously absurd. You construct them against things that are dangerously close to plausible.